Part C. Part C contains material aimed at technicians who maintain, service, repair, or dispose of high-pressure appliances, except small appliances and MVAC. The EPA defines high-pressure appliances as appliances that use a refrigerant with a boiling point between -50 degrees and 10 degrees centigrade at standard atmospheric pressure. This includes, but is not limited to, equipment using CFCs 12, 114, 500, and 502, HCFC 22, and HFC 134A. Very high pressure appliances use CFC 13 and CFC 503. Leak detection. When first inspecting a hermetic system known to be leaking, you should look for traces of oil. On a belt-driven, non-hermetic compressor, the most likely place for a leak when the compressor has not been used for several months would be around the rotating shaft seal area. When a trace gas becomes absolutely necessary for checking for a leak, use nitrogen with a trace amount of the system's design refrigerant to help locate the leak. A system that uses R407C should be leak checked with pressurized nitrogen and a trace amount of R407C. Excessive superheat is an indicator that there may be a leak in a high pressure system that operates with a capillary tube. The first thing to do when a new system has been assembled or built up is ready for testing is to pressurize with an inert gas and leak check. After installation of a field piped split system, the unit should first be pressurized with nitrogen and leak checked. The best use for testing with soap bubbles is to pinpoint the refrigerant leak. Leak repair requirements. Anytime that an air conditioning or refrigeration system is leaking, it is good practice to repair the leak. It is not only good for the environment, but it is also good business to repair the leak, thus saving your customer unnecessary repair cost. You should use good leak detection and proper repair techniques. Starting in 2019, a commercial refrigeration system containing 50 pounds or more of R22 must be repaired when 20% of the refrigerant charge has leaked out of the system. Starting in 2019, a chiller for comfort cooling that contains 50 pounds or more of R123 must be repaired when 10% of the refrigerant charge has leaked out of the system. The EPA has established 3 leak rate categories, being comfort cooling, commercial refrigeration, and industrial process refrigeration. As defined by EPA, air conditioning appliances used to provide cooling in order to control heat and/or humidity in occupied facilities, including but not limited to residential, office, and commercial buildings, fall under the leak repair category of comfort cooling. The leak repair category the EPA defines as commercial refrigeration is refrigeration appliances that are used in the retail, food, and cold storage warehouse sectors. So that'd be like restaurants or like MDI. To determine if the system is leaking more than the allowable rate, the EPA uses calculations based on component and pipe sizes to determine the full charge of the system. A company uses a chiller that diverts 55% of its cooling capacity to one of its manufacturing lines and 45% of its cooling capacity to air condition the office spaces. The leak rate category would be considered industrial process refrigeration. A customer that has an industrial process refrigeration system that contains 1,000 pounds of R22 that has exceeded the applicable leak rate threshold, the customer is required to perform a leak inspection every 3 months. When topping off an appliance that contains 50 or more pounds of an ozone depleting refrigerant, you are required to calculate the leak rate percentage. A comfort cooling appliance containing 50 pounds or more of R22 is found to be leaking beyond the applicable leak rate threshold. Unless granted additional time, you have 30 days to repair the leak and conduct an initial leak verification test. After a leak repair of a supermarket rack using 3,000 pounds of R22 and a successful initial verification test, you must conduct a follow-up leak verification test within 10 days. An initial leak verification test failed after repairing a leak in a rack refrigeration system for a supermarket using an HCFC refrigerant. They must conduct additional repairs within the 30-day repair window or develop to retrofit plan. If a certified service technician is not available to make repairs, the owner or operators cannot use this as a reason to extend the appliance repair deadlines. Once the leak rate threshold has been exceeded on a commercial refrigeration appliance with a charge of 2,000 pounds of R22, the owner must take further action by repairing, retiring, mothballing, or retrofitting the appliance. The owners or operators of an appliance with a full charge of 50 or more pounds of ozone-depleting refrigerant has 18 months to retire an appliance if the replacement appliance uses a refrigerant that is exempt from the venting prohibition. If a cold storage warehouse chooses not to repair an appliance containing R22 that is leaking above the threshold rate, the facility can continue to operate that appliance for 12 months before it must be retrofitted or retired, assuming no extensions apply. The owner operator of a supermarket system containing 50 or more pounds of R22 that has leaked more than 125% of its full charge in a calendar year must submit a report to EPA describing efforts to identify leaks and repair the appliance. The owners operators of regulated appliances normally containing 50 or more pounds of HCFC refrigerant must keep records of leak inspections, initial leak verification, and follow-up verification tests for 3 years. The owner or operator is not required to mothball an appliance using an ozone-depleting refrigerant, thereby extending the leak repair deadline if the appliance is removed and stored in a warehouse at a facility. An appliance normally containing more than 50 pounds of R22 refrigerant was found to have a 35% annual leak rate. After the repair, 2 successful verification tests are required. The first performed before the appliance is recharged, and the second performed after the appliance returns to normal operating conditions. Recovery techniques. The EPA has mandated that all refrigerants be recovered in a manner that will minimize as much as possible the release of refrigerants to the atmosphere. There are several methods by which refrigerants can be recovered, but remember that the most important thing is that you must not release refrigerants. A very important part of your service procedure is the correct operation of your recovery unit. Regardless of the type of recovery unit that you have, there are some basic recommendations for its use. When starting the recovery process, start first with liquid recovery. The liquid process will save time. To recover liquid refrigerant, you would connect a hose to the liquid line. Recovering refrigerant from a system in a vapor phase will minimize the loss of refrigerant oil. After refrigerant liquid has been recovered from the appliance, any remaining vapor is removed by the recovery system. And your recovery recycling machine has R22 refrigerant in it. You now have to recover refrigerant from a 410A unit. You must remove the R22 from the recovery unit and change the filter because you cannot mix refrigerants. You can speed up the removal of the refrigerant charge from a system by cooling the recovery cylinder to lower its pressure. The motor in a recycling and recovery machine with a hermetic compressor relies on the flow of refrigerant through the compressor for cooling to prevent overheating. Recovered refrigerant may contain acids, moisture, and oil. If the recovery recycling machine that you are using has a water-cooled condenser coil, use the local municipal water supply. Use gauge set hoses that have self-sealing connectors or hand valves to minimize refrigerant release when hoses are connected and disconnected. Refrigerant has been recovered from an air conditioning system and held in a refillable cylinder in order to replace the condenser coil. The refrigerant must be charged back into the system. Before transferring refrigerant into an empty cylinder, you should evacuate the cylinder. Service valve positions and recovery oil levels should be checked when applicable before using a recovery unit to remove a refrigerant charge. When the condenser is below the receiver, the refrigerant should be removed from the condenser outlet. And you have these stored. An operating unit that has a receiver storage tank requires refrigerant system service. When servicing, refrigerant should, let me start over. So an operating unit that has a receiver storage tank requires refrigerant system service. When servicing, refrigerant should be pumped down to and isolated in the receiver. So the refrigerant should be pumped down to and isolated in the receiver if you're servicing an operating unit that has a receiver storage tank required refrigerant system service. HVAC servicing companies are required to keep records for each disposed appliance with a charge between 5 and 50 pounds for 3 years. Recovery requirements: recycling and recovery equipment used for stationary refrigeration must be equipped with low loss fittings. It must be tested by an EPA approved third party, and equipment designed to recover flammable refrigerants must meet a specific UL safety standard. You are changing out the compressor of a system containing 40 pounds of R404A. In addition to isolating the compressor, you must evacuate the isolated section of the system to 0 psig. And if the pressure does not rise after a few minutes, you must remove the compressor. After reaching the required recovery vacuum on an appliance, you should wait for at least a few minutes to see if the system pressure rises. Before making a major repair, technicians must evacuate an appliance or component containing more than 200 pounds of R410A to 10 inches of HD vacuum. Appliances containing refrigerants can be recovered to atmospheric pressure when leaks in the appliance make recovery to the prescribed level unattainable. Repairs requiring the replacement of an evaporator coil would always be considered a major repair under EPA regulations. It is against EPA regulations to use a system-dependent recovery unit when the appliance contains over 15 pounds of refrigerant. Refrigeration. The state of the refrigerant leaving the receiver in a refrigeration system is in a high-pressure liquid. The best method to charge a system that has both an air-cooled condenser and evaporator with a nameplate charge of 80 pounds is to liquid charge through the liquid line service valve. The easiest way to check the type of refrigerant used in a 60-ton package rooftop unit is to look at the unit nameplate. You should replace the filter dryer in a system when it is opened for servicing. You should pull a level vacuum of 500 microns when evacuating a vapor compression system to assure all moisture has been removed. Oil foaming usually occurs in the compressor of a refrigeration system. The component directly following the condenser in a refrigeration system using a thermal expansion valve is a receiver. Using a temperature pressure chart, the approximate refrigerant pressure of an R410A machine at 80 degrees Fahrenheit room temperature while the machine is idle will be 238 psigs. A deep vacuum is usually measured in microns. Back seating the suction shutoff valve closes the gauge port. A moisture indicating sight glass is useful for checking moisture in the refrigerant. Refrigerant cannot be recovered without isolating a parallel compressor system because of an open equalization connection. An accumulator is located between the evaporator and the compressor in a refrigeration system. When under a deep vacuum, the motor winding of a hermetic refrigeration compressor can be damaged if energized. That means if you turn the power on. To avoid freezing the water contained in a water-cooled heat exchanger of an R134A refrigeration system during charging, the system should be initially charged with R134A vapor to a pressure of approximately 30 psigs. Non-condensables in a refrigeration system result in higher discharge pressure. The evaporation temperature of R134A at 0 psig is negative 15 degrees Fahrenheit. You should take an oil sample if a refrigeration unit has had a compressor burnout. Water in a system can freeze when using a large vacuum pump to evacuate a system. During evacuation with large amounts of moisture, it may be necessary to increase pressure to counteract freezing with a gas such as nitrogen. In a refrigeration air conditioning system, compressor heaters, crankcase heaters, are used to reduce the amount of refrigerant in the oil. So in a refrigeration air conditioning system, compressor heaters or crankcase heaters are used to reduce the amount of refrigerant in the oil. R123 refrigerant would be used in a low pressure appliance. To remove moisture from the refrigerant in a system, use a filter dryer. Liquid charging of an R410A refrigeration system with risk of freezing is begun with vapor from a vacuum level to a pressure of approximately 110 psig. Safety. The safe handling of refrigerants and their usage should always be of the utmost importance as you go about your normal service operations. Working with pressurized refrigeration systems and pressurized vessels always present a potentially hazardous situation. Listed below are some of the safety concerns that you may encounter when working with high-pressure refrigerants. 1. You have an R717 refrigeration system equipment room. A room refrigerant detector is not required under ASHRAE Standard 15, provided the mechanical ventilation system in the machinery room is run continuously. Number 2, a reciprocating compressor can be damaged if energized when the discharge service valve is closed. Number 3, use dry nitrogen to break the vacuum when dehydrating by the triple evacuation method. This requires a pressure regulator. Number 4, every refrigerating system must be protected by a pressure release device. Number 5, pressure relief valves can only be installed in parallel. Number 6, isopropyl alcohol should be used to remove ice from sight glasses or viewing glasses.